Usually when we talk about medical diagnosis, there is this comforting expectation of precision.
Right.
Like you break your arm, the x-ray shows that jagged white line on the monitor, and the doctor just points at it and says, there it is. There's the problem.
It's very objective.
Exactly. It's objective. It's contained. But then you step into the world of web development and enterprise content management, and suddenly that precision just, it completely vanishes into the ether.
Oh, absolutely.
Specifically, I am talking about that terrifying stomach-dropping moment that, if you're listening and you've ever managed a website, you know this intimately.
The publish button.
Yes. You know the exact moment. You have just spent 2 hours carefully formatting a new product landing page. You've tweaked the copy, you've uploaded the optimized images, you've double-checked the metadata.
And you're feeling good about it.
Right.
Yeah.
Finally take a breath, you hit that big publish button on your CMS, and then you just nervously jump over to a new tab with your live website and frantically hit refresh.
Hoping for the best.
Just praying, holding your breath, staring at a blank white screen for half a second, waiting to see if the layout completely broke.
Yeah.
You're wondering if, that hero image is suddenly the size of a billboard, or if the text is completely misaligned and overlapping your navigation menu because some CSS class conflicted.
It is a profoundly anxiety-inducing workflow.
Mm-hmm.
I mean, you are essentially dealing with a binary outcome, but in the most stressful way possible.
Right.
It either worked perfectly or it is a highly visible disaster that your actual customers are currently looking at in real time.
Exactly.
We are humans, right?
Right.
We like things to be visible, to be categorized, to be safe. But traditionally, in the headless architecture space, the gap between the back-end content repository where your text and images live as raw data and the front-end visual display where that data is actually painted onto the screen, that has been the absolute definition of muddy waters.
Yeah, you're essentially working in the dark, just tossing content over a point wall and hoping it lands in the right spot on the other side.
That's a great way to put it.
And that visceral fear, that constant friction between data and display is exactly why today we are taking a deep dive into the mechanics, the underlying architecture, and the complete technical setup of Contentstack's live preview.
It's a game changer.
It really is. We are going on a mission today to understand exactly how this real-time, zero-refresh contextual editing actually bridges that terrifying gap between your perfectly structured back-end JSON data and your beautifully rendered front-end visual experience.
Right.
Because, as it turns out, we have finally reached the point in web development where you simply do not have to work in the dark anymore. So let's unpack this.
Let's do it. Bridging this gap is not just about, providing a flashy drag-and-drop user interface to make marketing teams happy.
Though they do love that.
Oh, they love it. And it's certainly a benefit, but it is fundamentally about optimizing the entire content delivery pipeline.
Okay.
From a software engineering perspective, solving this problem without destroying the underlying integrity of the data structure is a massive, incredibly complex architectural challenge.
Because you don't want to break the back end just to make the front end look pretty.
Exactly. We are talking about fundamentally rewiring how content creators and developers interact with the final product simultaneously in real time without stepping on each other's toes.
So let's start with the magic trick itself. The what you see is what you get aspect.
The YG.
Right. From the everyday user's perspective, live preview is almost deceptive in its simplicity. It allows editors to see their content updates instantly.
And when we say instantly, we mean instantly.
Yeah, the documentation makes a big point of highlighting that they do not have to manually refresh the page.
Mm-hmm.
They do not have to wait for a staging server to rebuild the entire website.
No spinning wheels.
As they type a new headline in the CMS field, the actual text on the visual preview screen right next to it changes character by character. As they swap out a promotional image, the new image appears in the layout instantly.
It's incredibly fluid.
The documentation highlights 3 core features that make this possible. First is multiple device previews, allowing you to test responsive design on the fly. Mm-hmm. Second is contextual editing, meaning you can click directly on the visual preview pane to edit that specific piece of content. And third is immediate effect.
And that immediate effect, that is the variable that changes the entire operational calculus for a business.
How so?
Well, it is incredibly easy to dismiss this as just a nice convenience, right? A superficial quality of life feature for editors who are maybe just too lazy to click a refresh button.
Right, like a luxury.
Exactly. But the implications go so much deeper into operational efficiency, it drastically reduces public-facing errors.
Give me an example.
Okay, imagine a content manager writing a headline that looks perfectly fine in the raw text field. It's concise, it's punchy.
Sure.
But then when they see exactly how that headline wraps onto a second line on a simulated mobile screen, they might realize that a specific word is awkwardly orphaned at the very bottom.
Oh, yeah, like a tiny little word just hanging out by itself.
Right. And because they see it in real time, they rewrite the headline before they ever hit publish. They catch formatting errors before those errors ever reach the public domain.
That makes a lot of sense.
It ensures strict brand alignment. And most importantly, from a project management standpoint, it wildly accelerates the iteration process.
Because without this instantaneous feedback loop, what does the traditional headless CMS workflow actually look like?
It's a lot of waiting.
Yeah. You write the text, you save it as a draft, you trigger a webhook that tells your staging server to pull the new data. You wait, anywhere from 2 to 10 minutes for the server to run its build process and generate the new HTML.
And grab a coffee while you wait.
Exactly. You open a new browser tab, you load the staging URL, you scroll down to the section you edited, you realize the word synergy looks absolutely ridiculous hanging on a line by itself.
Yeah.
And then you have to go all the way back to step 1 just to delete that single word. The friction is just unbearable.
That friction completely destroys creative momentum. And with the omnichannel preview experience built into the system, the editor does not even need to physically pick up their smartphone or, open up the complex developer tools in their Chrome browser to simulate a mobile screen viewport.
They could just do it right there.
They can change aspect ratios on the fly directly within the CMS interface. They can view the desktop layout, click a single button, and instantly see the tablet layout, then the mobile layout.
Wow.
But here's the critical part from an engineering standpoint, what the underlying documentation refers to as the scope for innovation.
Okay, lead on me.
Live Preview is engineered as a core native feature of Contentstack's architecture. It is not a bolted-on third-party plugin or a visual overlay that hacks the underlying system to force a visual result.
Wait, let me stop you there.
Yeah.
If the end result is the same, like the editor gets to see what they're building, why does it actually matter if it is a native feature or a bolted-on plugin? A feature is a feature as long as it works.
Yeah. It matters deeply because of a concept called content schema integrity.
Content schema integrity.
Okay. Let's look back at the history of content management systems. In many older monolithic systems, or when using aggressive third-party visual page builders, getting a WYSIWG interface required a brutal compromise.
What was the compromise?
You had to sacrifice clean data. The CMS would stop saving just your text. It would start saving raw HTML tags, inline CSS styling, and proprietary layout shortcodes mixed right in with your actual content.
Oh, yuck.
Yeah, just to make the visual builder function, your database became a polluted mess of content and presentation.
I see. So it's all tangled up.
Exactly. With Contentstack's approach to live preview, developers still get the pristine, clean, structured JSON data.
Okay.
The API still delivers pure agnostic data that can be sent to a website, a mobile app, or a smartwatch. But the editors also get a visual playground. The two systems, the strict data model and the flexible visual presentation, they coexist perfectly without corrupting each other.
Okay, I see. So if you decide to completely redesign your website 3 years from now, you do not have to spend hundreds of hours manually deleting old CSS styling tags out of thousands of blog posts because the content was always kept completely separate.
Precisely. It future-proofs your data.
But I do have to push back a little here on the novelty of this.
Yeah.
Doesn't a standard CMS preview essentially do this same thing?
Yeah.
I feel like systems have had a preview button for over a decade. You click preview and a new tab opens showing what the page will look like.
That is a very common misconception about what is actually happening under the hood when you click a traditional preview button.
Okay, fool me.
Standard previews almost universally rely on a monolithic request-response cycle. When you hit preview in a legacy system, you are actually just hitting a save draft button in disguise.
Oh, really?
Yeah. You are forcing the front-end application to stop what it is doing, instructing the backend database to store a temporary version of the content, and then you are waiting for a full page reload so the server can fetch that new draft data, merge it with the HTML templates, and send the whole package back to the browser.
That sounds heavy.
It is. It is a strictly one-way street, and it requires significant processing time and network latency. Live preview, on the other hand, is instantaneous and, crucially, it is bidirectional.
Bidirectional, meaning the data flows both ways. How does that actually manifest for the person sitting at the keyboard?
Think about the hunt and peck nightmare of a traditional headless system. You
Yes.
look at the staging preview, you spot a typo and a legal disclaimer buried somewhere down in the footer.
All right.
You then have to switch back to the CMS interface and manually hunt through dozens of nested folders, modular blocks, and form fields to figure out exactly where that specific string of text lives in the database so you can change it.
It's like finding a needle in a haystack.
Exactly. With Contentstack's bidirectional live preview, clicking the visual element directly in the preview pane, clicking right on that typo in the footer, automatically triggers the CMS editor to navigate directly to that specific JSON field.
No way.
It flows from the back end to the front end for rendering and from the front end back to the back end for navigation.
That is a phenomenal workflow shift.
Yeah.
It is the exact difference between, like, sending a mock-up to a graphic designer over email, waiting 2 days for a proof, printing it out, circling a typo with a red Sharpie, scanning it, and emailing it back,
Right.
versus simply pulling up a chair right next to the designer at their desk, pointing directly at their monitor and saying, change that specific word right there, and watching them type it. The feedback loop drops from minutes or hours down to actual milliseconds.
It completely collapses the feedback loop, removing the cognitive load of translating a visual error back into a database location.
So if this feedback loop is truly instantaneous, we really have to pop the hood and look at the engine.
Let's do it.
To make this real-time magic happen, the CMS cannot just exist in a vacuum. It has to be deeply, fundamentally integrated with how the actual front-end website is built and rendered.
Very true.
Which brings us to the core concept of website architecture. The sources are very clear that when a development team decides to implement live preview, they absolutely must account for the specific rendering architecture of their site.
Yes, the architecture dictates everything.
And Contentstack supports the two major paradigms, client-side rendering and server-side rendering, or CSR and SSR. But the underlying mechanics of how live preview interacts with them are totally different, right?
They represent entirely different philosophies of how the modern web operates. Let's examine client-side rendering, or CSR, first.
Okay, CSR.
This architecture is highly prevalent with modern single-page application frameworks like React, Vue.js, or Angular. In a strict CSR environment, when a user navigates to a URL, the server does very little initial work.
Right.
It essentially sends down a nearly empty HTML shell, perhaps just a single, div tag, along with a massive bundle of JavaScript files.
Yes, a huge payload of code.
Exactly. That JavaScript bundle is downloaded into the user's browser, the client side. Only after the download is complete does the JavaScript execute, reach out to the various APIs to fetch the actual content data, and then mathematically construct and paint the the document object model right there inside the browser window.
I always like to think of client-side rendering like going out to a Korean BBQ restaurant.
Oh, I like this.
Yeah. The kitchen in the back, which represents the server, does not actually cook your food. They just bring you the raw ingredients, the raw data, and they set up a hot grill right at your table.
That's a great analogy.
The final rendering, the actual cooking of the meal, happens right in front of you, performed by you at the table. Now, it takes a minute to get the grill hot, which perfectly mirrors the longer initial load time of downloading that massive JavaScript bundle.
Right, you got to wait for the heat.
But once that grill is hot, once the app is loaded, you can cook bite after bite, navigate from page to page instantly, without ever having to go back to the kitchen and ask the chef to do anything.
The interactivity is incredibly high once that initial payload is parsed and executed. Now, how does Contentstack's live preview hijack that Korean BBQ environment to show real-time edits?
Good question.
When you open an entry in the CMS and the live preview pane initializes, the browser makes a standard GET call over the preview service URL to fetch the most recent draft data. So far, normal behavior.
Okay.
But then the editor changes something, say they type a new letter in the title field. Contentstack instantly sends a pass.ch call to its own backend, updating the draft. Crucially, the system then triggers a specific JavaScript listener function called onEntryChange directly inside the preview iframe.
OnEntryChange. Got it.
This function essentially taps the browser on the shoulder and says, hey, new ingredients just arrived from the kitchen. The browser then executes a new, highly targeted GET call, fetching just the updated JSON data for that specific field, and re-renders that specific piece of the web page instantly, all without ever reloading the entire HTML document.
Got it. So the browser's JavaScript engine is doing all the heavy lifting of calculating the new view and painting it onto the screen. It is highly localized.
Exactly.
But what about the other side of the coin? Server-side rendering, SSR. This is your Next.js, your Nuxt.js, your heavily SEO-optimized setups.
SSR fundamentally flips the script on where the computational labor happens.
Okay.
In an SSR architecture, when the browser requests a page, the server takes complete control. The server reaches out to the APIs, fetches all the necessary data, merges that data into the HTML templates, and generates a fully complete, structurally sound HTML document.
Wow.
It then sends that finished, ready-to-view document down the wire to the client browser.
Right. So to keep the culinary analogy going, SSR is exactly like a traditional high-end restaurant.
Yep.
You sit down, you place your order, and the kitchen does absolutely all of the work. They cook the meat, they arrange the sides, they garnish the plate perfectly, and the waiter brings you a fully finished, visually complete meal. It arrives perfectly ready to consume the exact second it hits the table.
The initial load time is lightning fast for the user because the browser does not have to think. It just has to display the HTML it was handed.
Right. No thinking required.
It does not have to parse a megabyte of JavaScript before it can show you a paragraph of text. This is why SSR is critical for search engine optimization, as web crawlers can read the fully formed content immediately.
But how does Live Preview handle that?
Well, how Live Preview handles this environment is significantly different and much more computationally expensive. When the web page initially loads in the Live Preview pane, the server builds the HTML via a GT call. Perfectly normal.
Okay.
But when the editor makes a keystroke change, Contentstack sends the patty.ch call to update the draft data. Now, because the browser in an SSR setup does not natively know how to rebuild the page structure, it relies on the server for that. The entire web page inside the iframe has to trigger a refresh.
Wait, the whole thing?
The whole thing. The server has to completely rebuild a brand new HTML page from scratch via a new GET call, process the templates all over again, and send that new finished meal down to the client.
Wait, if I am pushing a full server rebuild on every single keystroke in an SSR environment, wouldn't that massive overhead just completely melt my local node server or eat up all my cloud computing resources?
That is exactly the risk with poorly optimized SSR setups, and it introduces noticeable latency. The preview is no longer instant in the millisecond sense. It takes the time required for a full network round trip and server computation.
Ouch.
You are trading real-time, lightweight interactivity for structural SEO benefits. However, it is vital to note that modern web development rarely exists in these strict binaries anymore.
Right, there's always a middle ground.
Many modern frameworks utilize a hybrid approach, often called hydration.
Hydration, yeah.
They use SSR for the initial, incredibly fast page load, so Googlebots can read everything instantly. But once that initial HTML is painted on the screen, a background JavaScript bundle loads and hydrates the static page, turning it into a dynamic React or Vue application.
Ah, so it switches modes.
Exactly. From that point on, it switches to CSR routing for all subsequent user interactions. Contentstack's Live Preview SDKs are engineered specifically to gracefully handle these complex hydration handoffs, allowing developers to get the SEO benefits of SSR in production while still enjoying the localized, fast updates of CSR inside the CMS preview environment.
Okay, so we thoroughly understand where the rendering computation happens. But this brings up a massive, glaring logistical question.
Okay, what is it?
If I am the editor and I click my mouse directly on the word synergy on the visual front-end preview screen, how on earth does the system know exactly which specific field in the massive, complex back-end JSON database corresponds to that specific cluster of pixels on the screen?
It's a great question.
It seems like finding a needle in a haystack across two completely different technological dimensions.
That is precisely the core technical hurdle of contextual editing. You have a visual DOM tree on one side and a deeply nested JSON object on the other, and they speak completely different languages. The solution to bridging this gap is what Contentstack has engineered as live edit tags, specifically utilizing the data CSLP HTML attribute. This attribute is the absolute secret sauce of the entire operation.
Let's really get into the mechanics of this secret sauce. The documentation explains that these live edit tags are what make the bidirectional contextual editing possible. The SDK essentially acts as a scanner, searching the underlying DOM code of the web page for any HTML elements that have this exact data CSLP attribute attached to them.
The elegance of this approach lies in its automation. The CMS iframe needs a map. It needs a definitive way to know that the H1 tag rendering the hero text on the front end is directly, unequivocally tied to the string inside the hero headline field in the backend entry database.
Okay.
Now imagine if a front-end developer had to manually hard-code that mapping for every single element on a massive enterprise-scale website.
Oh, man. If a developer had to manually write mapping logic for thousands of text fields, images, and buttons, the technical debt would be catastrophic. The project would be completely unmaintainable.
It would fail before it even launched. This is where the Contentstack SDK steps in to do the heavy lifting. When a front-end developer is building their components, they implement a specific SDK method called addable tags.
Addable tags. Got it.
When the front-end application makes an API request to fetch the content data from Contentstack, this method intercepts the JSON response before it ever reaches the rendering components. It recursively iterates through the entire hierarchical data structure.
Wow, every level.
Every level. And at every single level, for every single field, it dynamically injects a brand new key value pair into the JSON object.
And the documentation explicitly mentions that this new dynamically injected key is always denoted by a $sign, correct?
Yes, the $sign acts as a reserved namespace. The value attached to this key is not content, it is metadata. It is an object that contains the exact absolute path back to that specific field's location inside the CMS database schema.
That's clever.
It creates an invisible breadcrumb trail tightly coupled to the actual data.
Let me make sure I'm visualizing this accurately for the developers listening. Let's say my normal JSON data path to find the height configuration for an image is data.description.height. What does the injected edit tag path actually look like when the SDK intercepts it?
The SDK intercepts it and transforms the path string to data.description.height. That crucial $symbol isolates the path metadata from the actual content data, ensuring the front-end application does not accidentally try to render the database path as if it were text meant for the user.
Okay, that makes sense for simple flat data structures, but modern websites are almost never flat.
Never.
Contentstack heavily utilizes modular blocks, which are fantastic for giving editors page-building flexibility, but they mean you can have a text field nested inside a layout block, which is nested inside a container block, which is nested inside a hero section.
It gets deep fast.
Yeah, the nesting can go 5 levels deep. How does a simple tag handle that complexity?
The path structure generated by editable tags accounts for infinite nesting natively. For deeply nested fields like those inside modular blocks, the generated path string looks something like this. It'll be modular block field UID dot block UID dot field UID.
Oh, I see.
It algorithmically captures the entire architectural hierarchy. So let's play out the scenario. The front end receives this data, and when it renders the HTML tag, it attaches that path string to the data CSLP attribute.
Right.
When the editor hovers their mouse over that element on the preview screen, a little edit icon appears. When they click it, the live preview window reads that specific data CSLP path string, sends a JavaScript post message back across the iframe boundary to the parent CMS window, and says, instantly navigate the database editor exactly to this deeply nested modular block field.
That is slick.
And even more impressively, if that element happens to be a reference field, meaning it is pulling content dynamically from an entirely different entry in the database, the system seamlessly jumps the editor out of their current context and directly over to that referenced entry's editing page.
That is an incredibly smooth orchestration of data. And there's a highly specific, very important technical detail buried in the sources here that I want to highlight for the modern JavaScript developers out there.
Go for it.
There is a configuration property on the SDK called tagsAObject. By default, this property is set to false, which means the SDK appends the data CSLP tag as a pure string. This is perfectly fine if you're working with older templating languages and just injecting it directly into plain HTML attributes.
Right.
But if you flip tags ASObject to true, it returns the tag data as an actual structured JavaScript object.
Well,
why is that distinction so critical?
That distinction is the difference between a clean code base and a nightmare of string parsing. If you are building a modern front end with a framework like React, you are not writing plain HTML. You are writing JSX.
Of course.
React components expect to receive data and attributes as objects so they can seamlessly spread those properties onto the underlying DOM nodes. If you pass a complex string of metadata into a React component and expect it to figure out how to parse it into an HTML attribute, React is going to throw errors.
It's going to crash.
Exactly. By setting tags AObject to true, the Contentstack SDK pre-formats the metadata perfectly. The React developer can simply use the ES6 spread operator to apply the object directly to the JSX element, completely bypassing the need to write custom regex or string parsing workarounds just to get the preview to render without crashing the application.
It is those tiny developer experience details that really show the maturity of an SDK. Okay, so we have the tags acting as our map, creating the bidirectional bridge. But to get those tags and to get the actual words and pictures flowing into the front-end application in the first place, we have to fetch the content from Contentstack's delivery servers.
We need the data highway.
Exactly, and the documentation lays out two distinct main highways for this data to travel. You have the GraphQL API, and you have the traditional REST delivery SDK. Let's explore GraphQL first. The industry loves to call it fetching the future.
GraphQL is an incredibly powerful paradigm, particularly for this highly specific use case of real-time live preview. To understand why, you have to look at the problem it was designed to solve, which is overfetching.
Okay, break that down.
In traditional REST APIs, the server dictates exactly what data is returned for any given endpoint. If you hit the article endpoint, you might get the title, the body, the author's bio, the publishing date, and a list of related articles, even if all you wanted to display was the title.
That's a lot of extra baggage.
It is. GraphQL flips that dynamic. It allows the client, the front-end application, to explicitly declare exactly what data it wants and the shape it wants it in. The client can request deeply nested relational data with a single HTTP request, and most importantly, the server returns only the specific fields requested, down to the exact byte. There is zero excess payload.
Which is obviously a massive win for mobile performance and bandwidth optimization. But setting up GraphQL specifically to power live preview requires some very deliberate steps.
Yes, it's not plug and play.
First, you have to generate a preview token in the Contentstack dashboard. Then, you have to integrate and initialize the live preview utils SDK within your front-end code using the Contentstack live preview.init method. And there's a major architectural point here. The documentation explicitly mandates that this utils SDK must always be initialized strictly on the client side, running in the user's browser, regardless of whether your overall architecture is heavily server-side rendered or client-side rendered.
The reasoning behind that strict requirement is purely mechanical. The live preview utils SDK's primary job is to act as an event listener.
Like it's eavesdropping.
Exactly. It sits inside the front-end application and constantly listens for the on-entry change JavaScript events being fired across the iframe boundary by the parent CMS when an editor types a key. Node.js running on a server in an AWS data center cannot listen to DOM events happening inside an iframe in an editor's Chrome browser in Chicago.
That paints a really clear picture.
That listening mechanism must physically execute within the client-side browser environment.
That makes perfect sense when you map out the physical location of the code execution. Okay, so when we call that init function in the browser, we pass it a configuration object to tell it how to behave. We have the enable Boolean, which obviously toggles the entire feature on or off.
Simple enough.
We have the concierge Boolean, which informs the SDK whether it should aggressively request a whole new HTML document on edit, or if it can just quietly update the JSON data client side. We pass stack details like the API key and the environment string. And then we hit the clientural params. This is where I start to see the complexity of enterprise architecture creeping in. You have to specify the host URL, but it changes completely based on your geographic region and your cloud provider.
This is a critical infrastructure detail that trips up a surprising number of developers, leading to frustrating debugging sessions.
I can imagine.
Contentstack is not a small platform running on a single server rack in a closet. It is a massive, globally distributed, enterprise-grade platform. They operate distinct, physically isolated hosting infrastructures across different global regions and across different cloud providers, primarily for strict data sovereignty compliance and to minimize network latency. So if your company's stack was provisioned in the North American AWS region, your API host is app.contentstack.com. But if strict GDPR compliance requires your stack to be hosted in the European AWS region, your host is u-app.contentstack.com. And they maintain completely separate routing hosts for Azure North America, Azure Europe, and Google Cloud Platform North America.
So the developer has to manually manage and verify these regional host names in their environment variables. That feels like a spot where a simple copy-paste error from a tutorial could just silently break the entire preview environment.
It absolutely will break it, and often silently. If you configure your front-end live preview utils to listen to the European host URL, but your actual content database lives on an Azure North America host, the WebSocket connection will simply fail to establish.
Oh, wow.
The editor will type, nothing will happen, and they will assume the system is broken. Meticulous attention to detail regarding this configuration object is paramount. And the configuration complexity does not stop at the SDK initialization. When you actually construct the raw GraphQL fetch request to pull the data, you have to manually modify the HTTP headers.
Let's dig into those headers. The documentation emphatically states that you must append two distinct pieces of information to the GraphQL request headers. You need the live preview hash, which essentially acts as a dynamic session ID, and the static preview token. Why are both necessary?
Let's break down the mechanics of a real-time edit session to understand why. When an editor logs into the CMS, opens an entry, and the live preview iframe initializes, Contentstack's backend dynamically generates a unique temporary session ID. That is the live preview hash.
Okay, the hash is the session.
Right. As the editor starts making keystrokes, changing images, and rearranging blocks, none of which are published yet, all of those real-time, unpublished changes are temporarily cached in the backend against that specific hash ID. Now, when your front-end GraphQL query fires off to fetch data to render the preview, it needs a way to tell the Contentstack servers, do not give me the globally cached, publicly published version of this web page. I need the highly specific, messy draft version associated with this one specific editor's ongoing session. Appending the hash to the header provides that exact context.
And what about the token?
And the preview token acts as the security bouncer. It proves to the server that this request is legally authorized to bypass the public cache and access sensitive, unpublished draft data.
So the hash tells the server where the draft is, and the token proves you have the right to look at it.
Perfectly summarized.
And because live preview needs these highly specific real-time data updates injected instantly, GraphQL is the perfect tool. You are not forcing the network to pull down the entire history and structure of the web page just because someone added a comma to a paragraph tag. But reading further into the sources, there is a massive flashing warning sign regarding modern JavaScript frameworks, specifically Next.js. Next.js is notorious for caching data incredibly aggressively by default to maximize performance.
Aggressive caching is the holy grail for production site speeds. It is why Next.js is so popular. It serves pages incredibly fast by never fetching data twice if it doesn't have to. But that exact same aggressive caching mechanism is the absolute mortal enemy of a live preview environment.
Really? Why is that?
Imagine the scenario. The editor changes a headline, the onEntry change function fires, triggering a new GraphQL request to fetch the new headline. The request goes out, but the Next.js internal cache intercepts it.
Oh, no.
The cache looks at the URL and says, oh, I already fetched data for this URL 5 minutes ago. Here is the old data. No need to bother the actual server. The front end instantly receives the old unmodified data, and the visual preview never updates.
So the editor is just sitting there typing into the void.
Exactly. The editor assumes the CMS is broken, they click save frantically, they refresh the page, they create massive version control bloat, and they file a bug report.
What a nightmare.
To prevent this disaster, the developer must explicitly add the cache, no store directive to their fetch request, when the application detects it is running in preview mode. This explicit directive forces the Next.js framework to completely bypass its own internal optimizations, go out over the physical network, and get the fresh, uncached data directly from Contentstack every single time a keystroke occurs.
That is exactly the kind of invisible gotcha that causes 3 days of pulling your hair out in a debugging session, staring at code that technically looks perfectly correct.
Well, we've all been there.
So, while GraphQL is clearly a precision scalpel for this job, some development teams still prefer to use the reliable Swiss Army knife, and that is the traditional REST delivery SDK. The implementation setup for the REST SDK differs quite a bit from the manual header manipulation required for GraphQL. Let's look at how that architecture is structured.
The REST Delivery SDK is the tried and true, heavily abstracted method. It removes a lot of the manual burden of cross HTTP requests, managing headers, and parsing raw JSON responses. To enable live preview in a REST architecture, you are interacting directly with the initialization payload of the core SDK itself.
Right. You define a live preview configuration object, and you pass it directly into the overarching content stack initialization function. This object requires that exact same preview token we discussed earlier, the enable boolean explicitly set to true, and again the crucial regional host string, but this time it is specifically targeting the REST endpoints, like rest-preview.contentstack.com, instead of the GraphQL endpoints.
And it is important to remember that just like with the GraphQL implementation, you still have to run the live preview utils SDK init method on the client side.
So they work together.
Yes. The two SDKs, the delivery SDK and the utils SDK, work in synchronized tandem. The utils SDK sits in the browser, acting as the ear, listening for the iframe change events. When it hears a keystroke event, it signals the delivery SDK, which acts as the muscle, actually executing the REST API call to fetch the newly drafted data.
Now, digging much deeper into that utils init configuration object, there are a couple of really fascinating parameters available here that apply to both fetching methods, but they are highlighted heavily in the context of security and user experience. First is the clean CSL peon production parameter. I find this one fascinating. Mechanically, what does this do and why it's so important?
If we zoom out and connect this to the bigger picture of application security, think about what those data CSLP live edit tags actually represent. As we discussed, they are literal hard-coded paths pointing directly to specific locations within your proprietary internal backend database schema.
Yes. You absolutely do not want developer data CSLP tags breeding out into your final public-facing production HTML for the whole world to see.
Exactly. It represents a significant security reconnaissance risk. If a malicious actor right-clicks your public website and hits View Source, and they see hundreds of tags explicitly detailing your exact internal database structure, your entry UIDs, and your content models, you are giving them a roadmap to your backend.
Yeah, it's terrifying.
Furthermore, beyond security, it unnecessarily bloats the raw page size. Injecting thousands of long-string attributes into the DOM adds measurable kilobytes to your HTML payload, which directly negatively impacts parsing performance and search engine ranking metrics.
So it's bad for SEO too.
Right. The clean CSL peon production parameter acts as an automated safety net against human error. Let's say a junior developer accidentally leaves the live preview initialization code running in the production build environment.
Which happens all the time.
If they have the main enable flag correctly set to false, but this clean CSL miden production parameter set to true, the SDK's initialization sequence will proactively scan the DOM and actively strip every single one of those editing tags out of the HTML before the final page is served to the public user. It is a vital self-cleaning mechanism.
That is a brilliant fail-safe against the inevitable reality of deployment mistakes. Another highly customizable facet of the init configuration is the edit button object. This controls the actual physical UI element, the little pencil icon that pops up on the screen when an editor hovers their mouse over an editable block of text or an image.
Yes, the edit button.
The documentation shows that developers can deeply, almost obsessively customize this button. You can enable or disable it entirely. You can write logic to exclude it from appearing if the site is being viewed inside the CMS preview portal, or conversely, exclude it if it's being viewed outside the portal on a raw staging URL.
You have a lot of control.
You can even toggle its visibility dynamically via URL query parameters. And finally, you can anchor its position in 8 different specific spots around the content element: top left, bottom center, top right, etc. Why offer that level of granular control over a simple edit icon?
The positional choice is particularly critical for maintaining a usable user experience within the preview environment. Think about modern, highly complex website designs. If you are previewing a dense, sticky navigation menu or a tightly packed grid of product thumbnails, a generic edit button that defaults to slapping itself in the top left corner of the element might physically obscure the very text or hyperlink the editor is desperately trying to review.
Well, that would be so annoying.
By giving front-end developers 8 different positional anchors, it ensures the CMS user interface does not cannibalize, obscure, or conflict with the actual visual design of the website being previewed. The tool adapts to the layout rather than forcing the layout to accommodate the tool.
Before we move completely away from rendering architectures, the sources briefly touch upon SSG, or static site generation, particularly in the context of the REST setup. How on earth does a real-time live preview system handle a site that is, by definition, pre-built into static, unchangeable HTML files?
SSG is a fascinating edge case here. Conceptually, SSG is essentially taking server-side rendering and doing all of the computational work ahead of time during a CI/CD build process, rather than waiting for a user to request the page. The server processes all the templates, fetches all the API data once, and spits out incredibly fast, completely static HTML files.
Right.
The problem is obvious. Static files cannot, by their very nature, update in real time. So when a developer is working with live preview on an SSG site, the Contentstack SDK forces the architecture into a hybrid state.
How does that work?
When the preview iframe loads, the server initially serves the fast static HTML file representing the currently published data. But immediately after that static paint, the client-side live preview utils SDK boots up in the browser, switches the application into CSR mode, fetches the latest unpublished draft data over the API, and dynamically uses JavaScript to replace the static content with the live content right in the browser DOM.
Okay, so it essentially falls back to the Korean BBQ method client-side JavaScript manipulation, specifically and exclusively for the CMS preview environment, while the actual live public-facing site remains a highly optimized static traditional restaurant delivery.
Exactly.
That is an incredibly clever architectural workaround. But as powerful, flexible, and well-engineered as this entire system sounds, there are absolute boundaries. No system is magic, and it is time to clearly outline the limitations of live preview, because it cannot do everything, and trying to force it to will only cause headaches.
Understanding the constraints of a technology is arguably just as important as understanding its capabilities. It prevents architectural dead ends. The documentation explicitly outlines several specific scenarios where Contentstack's live preview either fundamentally will not work or requires significant strategic workarounds.
The first limitation listed is pretty straightforward, but crucial for legacy migrations. Live Preview is strictly incompatible with third-party website builders or different HTML generation CMS platforms. If a company is putting Contentstack purely as a headless database backend, but their actual front-end HTML is being generated and hosted by a proprietary closed system like Wix, Squarespace, or a legacy monolithic CMS, Live Preview is simply not going to function.
The mechanical reason for that incompatibility is access. Contentstack's live preview requires the ability to freely inject those data CSLP metadata tags into the underlying HTML DOM, and it requires the ability to execute its custom utils SDK JavaScript library within the browser context.
And those platforms just block it.
Closed, proprietary rendering engines do not allow external systems to arbitrarily inject custom data attributes or listener scripts into their core templating pipelines. Live Preview fundamentally requires a custom-built front-end application where your engineering team has total, unfettered control over the codebase and the build process.
Another routing limitation. You cannot preview individual components unless they're explicitly referenced within a page entry.
This limitation comes down to the mechanics of URL routing. Let's say you have built a standalone component in the CMS, perhaps a complex newsletter sign-up form entry that you plan to reuse everywhere.
Okay.
But if that specific component entry is not currently attached to a parent web page entry that has a known resolvable URL route like About Us or Contact to Be, the live preview window literally does not know what web address to load in the iframe to show it to you.
It has no address.
An isolated piece of data cannot be previewed without a spatial context to render it within. It must be attached to a page that actually resolves to a URL in your front-end routing logic.
Here is one that I'm sure breaks some product managers' hearts. It completely lacks compatibility with native mobile applications. Why can't I use this incredible visual tool on a native iOS or Android app? I mean, headless architecture is supposed to be omnichannel.
It is fully omnichannel for data delivery, but visual previewing is a whole other beast. This limitation highlights the fundamental, unbridgeable difference between web rendering technologies and native compiled rendering. Live Preview works exclusively by placing an iframe, which is just a miniature web browser window side by side with the data editor, and using standard JavaScript to manipulate the HTML document object model, the DOM. Native iOS apps built in Swift or native Android apps built in Kotlin do not use HTML. They do not have a DOM. They use proprietary native UI rendering engines provided by Apple and Google. You mathematically cannot inject a web-based iframe side by side with a web editor and expect a web script to actively manipulate compiled native mobile UI components in real time. The technologies speak entirely different, incompatible rendering languages at the deepest system level.
That makes total sense when you break it down. You cannot use a web-based JavaScript tool to hot swap native compiled code running in an emulator.
It's just not possible.
The documentation also notes that previews are strictly governed by user roles, environments, and language localizations. If a junior content writer does not have the administrative permission to view the French translation of the staging environment, they cannot magically bypass that security restriction simply by opening the live preview window.
The API enforces the permissions globally.
But the final limitation listed is easily the most technical, the most frustrating, and probably the most common stumbling block for developers setting this up for the first time. The front-end website must be strictly iframe compatible to prevent CoreR's errors. Okay, I need you to deeply unpack CoreR's for me because it's the bane of every junior developer's existence.
CoreS, which stands for Cross-Origin Resource Sharing, is arguably the most misunderstood concept in web development. To understand it, you have to understand the same origin policy, which is a fundamental foundational security mechanism built directly into every modern web browser by default.
The same origin policy.
Essentially, the same origin policy strictly prevents a potentially malicious website from embedding your banking website inside a hidden, invisible iframe, tricking you into typing your password and stealing your keystrokes. Browsers categorically restrict web pages from making API requests to or being embedded by domains that are different from their own origin domain.
Okay, so applying that to our situation, because the actual Contentstack CMS editor interface lives out on the internet at app.contentstack.com, and my local development website is running on my laptop at localhost.3c00, or my company's staging site is at staging.mycompany.com, my Chrome browser looks at those two completely different domains trying to talk to each other and instantly panics.
Precisely. When the Contentstack CMS attempts to load your localhost website inside the live preview iframe, your Chrome browser steps in like a security guard and says, wait a minute. I see app.contentstack.com attempting to embed localhost 0.300. But localhost 0.3000 never explicitly gave permission to be embedded by this external domain. This looks like a malicious clickjacking attack. I am terminating this connection.
Wow.
And live preview completely breaks. You will not see an error in the CMS UI. You will just see a blank white screen or a sad face icon in the iframe, while your browser's developer console screams about Core's policy violations in bright red text.
So how does a developer actually fix it and prove to the browser that this is a safe intended interaction?
The developer must explicitly configure the HTTP response headers of their front-end application to allow the embedding. Specifically, they need to manipulate the content security policy header or the older Xframe options header to explicitly whitelist the exact Contentstack app domain.
They have to build a whitelist.
They have to configure their server to tell the browser, yes, it is fully authorized and safe for app.contentstack.com to embed this specific site in an iframe. If the developer skips this critical security configuration step, absolutely nothing else we have talked about today matters. The browser will kill the preview before the SDK ever even loads.
That is a massive warning sign. Do not skip the CoreS headers. So we have spent all this time talking deeply about the real-time magic that happens inside the CMS interface. But what if you are not inside the CMS at all? What if you are a content manager or a marketing director just casually browsing your live staging website? You spot a glaring, embarrassing typo in the About Us paragraph, and you just want to fix it quickly.
Normally, that triggers a tedious workflow.
Yeah, you have to open a new tab, log into the CMS, navigate through 15 nested folders, figure out which exact database entry corresponds to the specific page you are looking at, find the right nested field, and then finally type the correction. It is immense friction for a small task. But the documentation highlights a powerful shortcut specifically designed for this workflow.
Yes, the Contentstack Chrome extension, it is essentially a workflow cheat code that reverses the entire live preview paradigm.
Explain how it reverses the paradigm. Because what this means for a user is seamless, frictionless transition. If you install the extension in your browser, and you are logged in with the correct editing permissions, a little Contentstack Edit button magically appears directly hovering over the live web page itself as you browse.
That's so cool.
Clicking that button completely bypasses the entire hunt and peck process. It instantly opens a new tab, authenticates you, and drops you directly into the exact corresponding entry in the Contentstack backend, immediately ready to edit.
Exactly. Instead of bringing the visual website into the CMS via an iframe, the extension brings the CMS access directly to the visual website. But it is not actual magic. It requires some very specific technical setup on the developer side to make the Chrome extension aware of what backend data it is actually looking at when it scans the live HTML.
Right. The basic setup requires you to configure the extension itself by pasting in your Stack API key, your hosted domain, and your region into the browser pop-up. But that is not enough. You actually have to modify your front-end website's underlying code, specifically the body tag of the HTML document.
Yes, the body tag.
You have to instruct your developers to add 3 highly specific data attributes to the body tag. You need beta pageref, which must hold the unique entry UID for that specific page, data content type, which holds the overarching content type UID, and data locale, which specifies the exact language translation being viewed.
Let's look at the mechanics of why the extension absolutely requires those 3 tags. The Chrome extension does not actually know anything about your backend database structure natively. It acts as an authorized web scraper. When you click that hovering edit button, the extension's JavaScript immediately scans the current page's DOM. It specifically searches the body tag for those exact data pageref, data content type, and data locale attributes. It extracts the raw UID strings from those attributes and then mathematically constructs the exact administrative URL required to route you directly to that specific entry in the Contentstack dashboard.
Without those 3 data points embedded in the HTML, the extension is completely blind.
Completely blind.
And I really appreciate the practical, developer-friendly instruction included in the documentation regarding how to implement this. Because if your enterprise website has 10,000 pages, manually hard-coding those 3 attributes onto every single HTML body tag by hand would be an absolute nightmare and prone to massive human error.
Oh yeah, you don't want to do that.
The source documentation specifically advises developers to create a global helper function, because your server-side rendering template or your core React layout component already mathematically knows what database entry it is currently rendering. You can write a tiny reusable script that universally and dynamically applies these 3 data tags to the body across the entire site automatically during the build process. Set it up once, and the extension works universally forever.
Automating the metadata injection is the only sustainable way to manage it at scale. It removes the hidden element entirely from the configuration.
I always love a good, elegant helper function. Okay, we have covered an immense amount of technical ground. We have unpacked the rendering architecture differences, the intricacies of API fetching, the metadata tags, the hard limitations, and the browser extensions. If the listener out there is tired of theorizing and wants to actually start writing code and building this themselves, where exactly do they start? Contentstack does not just leave you with a dense manual and wish you luck. They actually provide dedicated environments to test and break this implementation safely.
Practical hands-on application is the only true way to understand a system with this many interconnected layers of complexity. The documentation strongly emphasizes that Contentstack provides a free 30-day training instance sandbox, or even an extended 90-day training stack for developers actively pursuing official certification.
That's great.
This is a fully functional, isolated cloud environment where you can practice configuring webhooks, manipulating headers, and testing routing without any fear whatsoever of accidentally breaking a live, revenue-generating production site.
Because, let's be totally honest with each other, setting up live preview correctly involves manipulating HTTP headers, managing security tokens, configuring complex regional routing URLs, tweaking Next.js caching layers, and wrestling with CORS policies. You are absolutely going to break things, misconfigure a URL, or get blocked by the browser on your first try.
Guaranteed.
Doing this in an isolated sandbox is the only psychologically safe way to fail, debug, and actually learn the mechanics.
Exactly. And to guide that learning process, the Contentstack Academy offers deep dive, step-by-step video walkthroughs specifically designed for setting up Next.js 14 local applications with separate dedicated videos for both strict client-side rendering and server-side rendering modes. They literally walk you through the necessary code modifications, line by line, explaining the why behind the what.
And I have to point out a somewhat humorous but very real hyper-specific quirk mentioned in the sources for anyone who actually goes and watches those tutorial videos. There's a big bold note that essentially says the SSR video uses a specific Next.js 14 sample application that might differ slightly from the sample code currently available in the Active Sample Starter app's GitHub repository.
That's hilarious.
So developers should not panic if the code in their IDE looks slightly different than the code on the instructor's screen. It is just the hilarious, frustrating nature of fast-moving JavaScript frameworks where syntax changes every few months.
That is the daily reality of modern web development. The specific framework syntax or the folder structure might shift slightly from version to version, but the underlying architectural concepts, the required get t and patch API calls, the necessity of the data CSLP metadata tags, the strict core security requirements, Those core mechanisms remain constant regardless of what JavaScript framework happens to be popular this year.
The fundamentals don't change.
And beyond the videos, there is a massive wealth of technical resources available. You have the official API docs, the troubleshooting FAQs, the deeply technical live preview blog, the Academy Playground GitHub repo, and sample starter apps that you can bootstrap and spin up right from the command line interface in minutes. To complete the actual certification course, you just need basic administrator or developer access to a stack and the permissions to create a new live preview environment.
Okay, we have taken a massive journey today. Let's briefly recap the core mechanics we have uncovered. We started by understanding the profound operational shift that the instant magic of live preview provides, completely eliminating the blind, terrifying publish and pray workflow while maintaining strict content schema integrity.
Right.
We navigated the dense, consequential architectural differences between client-side and server-side rendering, exploring how the system either updates data instantly via JavaScript or forces a full server rebuild. We learned the absolute secret sauce, how the SDK recursively injects live edit tags with the data CSLP attribute to map the front-end visual DOM perfectly back to the back-end nested JSON.
The crucial bridge.
We explored the surgical precision of fetching data with GraphQL versus the abstracted reliability of the REST delivery SDK and how to avoid the trap of Next.js aggressive caching. We acknowledged the hard technical boundaries, like the impossibility of manipulating compiled native mobile apps and the headache of core security errors. And finally, we saw how the Chrome extension creates a brilliant, time-saving, direct shortcut from the live public site directly back to the CMS editing interface.
It is a profound, fundamental shift in how we handle content architecture and organizational workflows. And looking at the sheer power of this bidirectional link raises an important, almost futuristic question.
I'm listening.
If live preview can truly bridge the gap so flawlessly between perfectly structured, database-agnostic back-end JSON data and front-end visual rendering in absolute real-time, how might this shape the future of back-end development itself?
Oh, interesting.
Right now, we are primarily using it as a tool for content editors to safely edit text and swap out promotional images. But are we rapidly moving toward a reality where content editors can visually, organically no-code their own complex backend database schemas simply by dragging and dropping new structural UI elements directly within the visual preview pane itself?
Wow.
If the bidirectional data link is truly this strong, the historic rigid line between the content editor simply filling in blanks and the database schema architect designing the structure might start to blur out of existence entirely.
Now that is a fascinating thought to leave on. A completely visual schema builder tied directly, inextricably to the live render. Well, for you listening, the next step is crystal clear. Go spin up that 30-day training instance sandbox, generate your preview tokens, pull down the Next.js starter app, and try your absolute hardest not to get blocked by CoreOS on your very first try. Thank you for joining us on this deep dive into the mechanics of Contentstack's live preview. Hopefully the next time you have to hit that publish button, you won't have to hold your breath anymore.